Okay, so this is lesson 4, continuing with volume, but we're going to look at volume of pyramids and cones and kind of lump these together because they're basically essentially the same type of shape, except the cone has the circular base, but they meet at the top at a point. So you do get these on the reference sheet, and the formula for a pyramid, whether it's a rectangular pyramid, a triangular pyramid, whatever, it's 1/3 capital B, that stands for area of the base, times h, which is the height. So that's area of the base. And the formula that you get on the reference sheet for a cone is 1/3 pi r squared h. It's essentially the same thing because pi r squared, that is the area of a circle, and the circle is the base of a cone. All right, so if we look at these basic examples here, we have a square pyramid because the base is a square. So the volume is going to be 1/3. The base is a square, so side squared times the height. So volume is 1/3, 756 squared times 481. And then we can go ahead and put that in the calculator. Okay, so I'm putting that in now. 1/3 times 756 squared times 481. Okay, so pretty large number here. 91636272, and it's going to be feet cubed. Okay, and then the cone here, volume is 1/3 pi r squared h. Okay, so 1/3 pi, the radius is 4, and the height is 6. And we'll leave this in terms of pi. So when I put this in the calculator, I am not going to put the pi button in. And I get 32 pi inches cubed. All right, let's look at the first example here. A right circular cone is shown at the right. The radius of the cone is 5 meters, and the volume of the cone is 100 pi meters cubed. Find the height h of the cone. Okay, so this one's a little different because we have the volume, and we want to find the height h. So volume is 1/3 pi r squared h. And this time we have the volume, so I could replace 100 pi with the volume. And the radius is 5. And we're solving for h. So we'll clean that up a little bit. Okay. So we have 100 pi equals 1/3 times 25 would be 25/3. Okay. So we need to get h by itself. And if you wanted to, you could have you didn't have to have this step. You could have just at this point divided both sides by 1/3, by pi, and by 25. Okay, because that cancels all of this. So I'll show you how to put this in the calculator. Okay, so it's probably best to use your alpha y equals to get a fraction. And we had 100 pi. And we're dividing by alpha y equals, let's get 1/3. It was pi and 25. And then hit enter. So I'm using the horizontal division bar, so this way I don't have to worry about parentheses. and we get 12. So the height equals 12. Okay. Part B is asking us for the slant height S. So we want this slant height. To get the slant height, we have two sides in a right triangle. So we can use the Pythagorean theorem. A squared plus B squared equals C squared. So this is a Pythagorean triple, meaning that it's going to work out really nicely here. 25 plus 144 equals x squared. And square root both sides to get 13. So our slant height S is 13. So just an important thing to make note of, for the volume of a cone, the height that we always want is this vertical height here. So if you're given the slant height, you might need to use a Pythagorean theorem to get the vertical height, because that's what you need with the volume formula. All right, I'm going to skip a bunch of these 2, 3, 4. I'm going to go straight to 5. Okay. We have a water tower in New York City, has the shape of a cylinder with a cone on top. The cylinder has a diameter of 12 feet and a height of 15 feet. The roof has an inclination angle of 25 degrees. Determine the height of the cone to the nearest tenth of a foot. So we need to find this height right here. And we'll need that height then to find the volume. Okay, couple things we could fill in. Since they tell us the diameter, the diameter of this cylinder is 12 feet, that's going to make the radius 6 feet. Okay, and the next thing here is they give us this cross-section of the roof. So we want to find this height. We have that this is 6. Okay, so we have an angle measurement. We have a right triangle. Hopefully you're kind of thinking that, hey, we could use trig for this. So let me redraw out the right triangle here. Okay, we have this is 6. We have this is 25. And we want to find this height h. Okay, if we're working from this angle here, we have an opposite and an adjacent, which means we can use tangent. So I could say the tan of 25 degrees equals opposite over adjacent. Put this over 1 and cross multiply. Okay. And then use your calculator. So just make sure you are in degree mode. And then we could do 6 tan of 25. And to the nearest tenth, that's going to be 2.8. Okay. Now it's asking us for the volume of the tower. The tower is made up of a cone and a cylinder. Okay, so the cone. The volume of a cone is 1/3 pi r squared h. Okay, the radius is right here. That's going to be 6. And we just solved for the height, which was 2.8. Let's use our rounded answer of 2.8. Okay. I am going to leave the volume in terms of pi here. I won't round until the very end. 1/3 times 6 times 2.8 is 5.6 pi. And that's feet cubed. Okay, now I'll do the cylinder. And the volume of a cylinder is area of the base times the height. The base is a circle, so pi r squared times h. Okay. The radius of my circle for my base is also going to be 6. So pi 6 squared times 15. I just realized I made a mistake on the last one. This should be 6 squared over here. So let me fix that. Sorry about that. So 1/3 times 36 times 2.8. So I'm just going back to the last one. That should be actually 33.6 pi. Okay, let me do now the cylinder. Sorry about that. 36 times 15 is 540. So 540 pi. Okay, we want volume of this whole thing. So we're going to go ahead and add 33.6 pi plus 540 pi. And we'll round to the nearest cubic foot. Okay. So when I round, that's 1802 feet cubed. All right, last part here. It says there are 7.48 gallons, 7.48 gallons equal to 1 cubic foot. If residents of the apartment building are using the water from the tower at an average rate of 56 gallons per minute, determine how long it will take to drain the entire tower. Okay, we have a little bit of an issue here because our tower is in cubic feet and they're talking about it draining in gallons per minute. So let's convert to gallons. Okay, so it's 7.48 gallons per cubic foot, and we have 1,802 cubic feet, which means we could just multiply 1,802 by 7.48. Okay, so I'll do that real quick. And now we have a tower of 13,478.96 gallons. Okay, so our tower has been converted to gallons. Okay, it's draining at an average rate of 56 gallons per minute, which means we could divide by 56 gallons. Okay, when we do that, that means it's going to take 240.6957 ... minutes. And they're asking us to determine how long it'll take. Do they say to the nearest minute or anything? They do not. Let's just round to the nearest minute here. So it's going to take 241 minutes to drain the entire tower. All right, so hopefully I will be back tomorrow and I'll clean up any questions you might have, and then we'll just kind of move forward in the unit. All right, see you everyone. Bye.